Hello class, and welcome to our first lesson on waves. In this lesson we're going to be focusing on SAP 4 letter A, which deals with the characteristics of electromagnetic and mechanical waves. This is kind of looking at, first of all, before we get deep into the wave nature of sound and electromagnetic radiation, we're going to start by looking very basic at some different characteristics of electromagnetic and mechanical waves. So our I can statement for this lesson will be I can identify characteristics of electromagnetic and mechanical waves. Please make sure that we write that on our student-friendly standards chart in our notebooks. So let's talk about just some basics about what a wave is, because we've all experienced waves before. A lot of times when we think about waves, we think a lot about water waves, but those are not the only types of waves. A wave is actually, it is a disturbance that carries energy but not matter. So when a disturbance goes through matter and it's carrying energy, then you will produce what is called a wave. Waves are created by some type of source. There has to be some type of source that creates these waves, and they travel through what we call a medium. And medium is just matter, which can be a solid, liquid, or a gas. Look at the sentence below and see if you can figure out the source and the medium. A ripple forms when raindrops hit the pond. What is the source? If you said a raindrop, then you are correct, because the ripples in the pond were formed by the raindrop, so that was the source of the wave. What is the medium? What is the wave traveling through? If you said pond, then you are correct. The wave is traveling through a pond, therefore making it a medium. A model for waves here, when you're thinking about a wave traveling through matter and carrying energy but not actually moving the matter, think about people passing a ball down a line. The people could represent the matter, and then the ball would represent the wave. So the ball is going from person to person in the line, but those people are staying in their exact location. They're not moving location. However, the ball is continuing to move down the line of people. That will represent the wave. So waves will travel through matter, but they're not carrying matter with them. So they carry energy, but they don't carry matter. Now, let's talk about the two types of waves. First, let's start with the mechanical waves. Mechanical waves is one of the main types of waves. So whenever we're talking about waves, waves are either going to fall under the mechanical waves or the electromagnetic waves. Those are the two main types. Waves that use matter to transfer energy are called mechanical waves. In order for mechanical waves to carry and transfer energy, there has to be some type of matter or medium for those waves to travel through. Now, previously said, the matter through which a mechanical wave travels is called a medium. Remember, a medium can be a solid, liquid, or a gas. For the ripples on a pond, the medium would be the water. That's what the wave is traveling through. Now, let's talk more specifically about some different types of mechanical waves. Now, we can break it down even further and classify mechanical waves as either being transverse or compressional. Let's look at the transverse wave first. Now, the big difference between these two waves is how they cause the matter to move whenever they travel through it. With a transverse wave, it causes the matter to move up and down and back and forth at right angles to the direction the wave travels. Just to kind of get an idea of this, a good example of that would be an ocean wave. And many of us have seen ocean waves or been to the beach and seen ocean waves before, maybe seen them on TV, but they have that kind of up and down motion. And you see sometimes you can see a very high point on that wave as it's coming in and crashing on the beach. But it's always kind of perpendicular or making a right angle with the water. Okay, so that would be an example of a transverse wave. Another example of that would be a seismic wave, which is earthquake waves, and they travel through the land, which would also be very similar to a transverse wave. Transverse wave have parts such as a crest, a trough, a wavelength, and an amplitude. Now, we will go into more detail about these parts in another lesson, but make sure that we're recording this information on our graphic organizer so you are familiar with some of these parts. Here's an animated picture of a transverse wave. You've got the people moving in a direction, and you've got the wave moving in a direction. Now, the wave is moving from left to right. Okay, however, the people are moving up and down, therefore forming that right angle that we were talking about. And this is what we call a transverse wave. Now let's look at a compressional wave. A compressional wave will make the medium move forward and backward along the same direction. So with a compressional wave, you've got the medium and the wave kind of moving back and forth in the same direction. When it goes through, it causes the matter just to kind of go back and forth in the same direction that the wave is traveling. An example of this would be a sound wave. And then some parts of a compressional wave is a compression, a rarefaction, and a wavelength. Make sure we record these on our chart. And like I said, we'll go into more detail about these different parts in another lesson. Let's look at how a compressional wave moves. So a little bit different from the transverse. The matter is not moving up and down, it's just kind of moving back and forth. So the wave kind of travels through the matter, makes it kind of bounce back and forth as it's going through. And this is what we call a compressional wave. Now, let's talk about the other type of wave, which would be an electromagnetic wave. Electromagnetic waves are the ones that can travel through space where there is no matter. These are some of these waves can be very, very strong and very powerful. And you may notice over here on this chart, you may notice some of these waves. A lot of these waves are used in a lot of our different devices and things that we have made our lives so convenient. For example, microwaves are responsible for microwave ovens and them being able to warm up and cook foods very fast. X-rays, many of us have been to the doctor before and have had to get an X-ray done. These are also electromagnetic waves. Now, electromagnetic waves are considered transverse because they have the same shape as a transverse wave, which means they have a crest, they have a trough, they have a wavelength. They have some of the same parts that a transverse wave would have. So they have the same shape. And if you kind of look down here at this shape, you'll kind of see how it does have that same shape as a transverse wave. Now, the difference with it is that, of course, the electromagnetic wave is made up of what we call a magnetic field and an electric field. We just recently talked about the relationship between magnetism and electricity. Well, it's going to come into more, or we're going to talk about it more as we explore electromagnetic waves, looking still at that relationship. But this will be a picture of what an electromagnetic wave would look like. And these are some other examples of some electromagnetic waves. And like I said, it has some similar parts to what you may find on a transverse wave. That ends our lesson on types of waves. Make sure that you have completed your graphic organizer and you filled in all of your parts. If there's something that you're missing, please make sure that you go back and input that onto your graphic organizer.